Hey everyone, welcome back to the channel, Simpit Academy. In the previous two videos, we looked at the VHF and UHF panels with the primary focus on the 7 segments. So the A10 is one of the most complicated cockpits to build. It has the most number of panels over all other aircrafts, whether it's the Hornet, the Viper, the Strike Eagle, and maybe F4, some whatever. So yes, so many panels, and in all the many panels of the A10, I think 7 segments is the most complicated thing to build. So from there, it's like downhill. Everything is relatively easier. So today we look at the new ARC-210 panel, and this radio has both VHF and UHF and also satellite radio, but I believe this is the satellite part is not implemented yet, but I could be wrong. So I haven't really um, flown the A10 and work on the radios for a while. So anyway, we'll build this panel today, and this is relatively easy compared to those with 7 segment, which has complicated coding, complicated wiring. So this one is relatively easy. Yes, it still has many buttons and rotary switches and encoders, but no complicated wiring. Okay, so let's start. So this one looks very busy, very chaotic. Again, where you place all this, whatever changes you want to make, all depends on your choice of switches. So you can see the original buttons are all very narrow. I usually don't care to conform exactly the same. I use whatever that's convenient to me, and I like this square button, or even though it looks different. Okay, so I make it bigger. Even here they are all bigger, and then instead of these two, like one button up, one button down, I just combine it into one rocker, and my rocker is like kind of short and fat. Okay, same thing here, two rockers here. This one is supposed to be a long push button. I just use a standard square button. So and anyway, this enter button is not functional, so I don't really care how it looks. Okay, so primarily you see the two parts here in purple. This is the original bottom, original top of the top panel, and I shift everything. I shift this up by 1 D-Zeus spacing, and same thing for the bottom. So the whole panel is like 2 D-Zeus spaces taller. Okay, the whole console is actually quite long and a lot of spare spacing. So in changing the panel a bit taller doesn't really matter because you're not going to run out of space. Okay, so I find it much easier than trying to squeeze everything. So I just spread out. So the top, I push things up, here I push things down, and here it gets less crowded. So you see a lot of space, but actually you need text at the top of this, at the bottom of this, so you need a lot of text everywhere around the buttons. So I just decided to spread it out. Okay. It doesn't matter if you cannot really read the numbers because your choice of switchers and where you want to place them is going to be different. Okay, this gives you an idea. So you notice I shifted this to the left quite a bit, and I'll show you why later. So we have the lines, this arrow, and then we have this I only extended it down a little bit, but definitely all the encoder holes are much further down, and all these are much further down, the rotary switches. So the key thing is all this in green are omitted, right? I find it not necessary to have them. Then I don't need a very precise alignment. Okay, just have the text, and where it roughly points in that direction, you are good. So if you have the line and your indicator line on your knob doesn't line up with the line on the panel, then it's going to look off, right? So um, I I remove this, and I also remove all this, right? And you can see this one, the original one is like a 30, 60, 90 um, setup, and I tend to use 45 degrees turn for my rotary switches. So, and I just spread out everything. Okay, so that's for the lines and skipping some, the green ones. Next is we add the text, and as usual, I don't use the original text. I use my own text, which tends to be slightly bigger. The most common one I use is 4.5 size font. This one, because it's so crowded, I use a 3.5. Sometimes I use a 4. And then all the typical name of the panel, I use the biggest size, font size, 6. Okay, everything else here is like 3.5. So this one, the way you align it is you draw lines, and then you place the text around like 45, 45, 90, 0, stuff like that. Then you hide the lines, okay, to help you place the text. So the bottom of the panel, this build we work backwards. We do the top panel first, and then we do the back panel later, because the top panel decides everything where it goes. So at the bottom, these are the bottom recess for all the nuts, okay? That will be sitting on top of the back panel. So here we have various recess. So you have typical recess for the nuts is 3 mm, and our panel is 6. So these are recess for all the push buttons, and they need a deeper recess because of the thickness of the button. Okay, if you don't have a deep enough recess, the top panel will not sit flush on top of the back panel. So all these are 4 mm, and then this part here, the way I put the screen on the back panel is going to just protrude up a little bit. So I just need a 1.5 mm recess. I don't want a deep recess like this as well, else you'll see a gap from the top. You see a lot of gap between the top panel and the back panel. Okay, so 3 mm recess for all the shaft holes, 4 mm for the push buttons, 1.5 for the screen. So this is the completed panel, top panel, how it looks like. So this one, the light icon, I just shift it up. So that's about it. Oh, one thing I forgot to mention is the corner fillets kind of standard 1.5 mm, but these 4 corners here, it's a much bigger curve, so they are all at 5 mm. Okay, that's how it looks like. So as you can see, this is the original shape, right? Like 10% smaller. So for the knobs, just like the VHF and the UHF, I skip using this for all the frequency knobs. This encoder is kind of like standard encoder, and they are very thin and brittle and fragile legs that if you accidentally pull the wire, it breaks, right? So I really hate using this. I usually use this for like the volume switch in replacement of parts. Other than that, for all the frequencies, I also use this type here, and but because they are much bigger, I need to add some stuff to push down the whole thing a little bit more. See, this is the back panel, this is the top panel, so they only protrude a bit, but these are the original knobs that Romeo Kilo also provided, but you can see here this part here, because it's at the top is very narrow, right? So this encoder cannot really go up much, so they are only, you know, the shaft hole is very shallow and it doesn't grip well because these are much bigger encoders and they are harder to turn. Like this one is very loose, it's very easy to turn, and these knobs will fit this, but I'm not using this. So these are, first of all, wider, it doesn't fit, and if you widen it, um and because of the shallowness of the shaft hole, it doesn't grip well, and if you widen it too much, it starts to break at the sides. Okay, so I tried it and they all get damaged, so I decided to make my own, okay, to fit this much bigger encoder. And also you see the provided knobs are all engraved lines, and I do things the opposite. I don't have a CNC machine to engrave. I emboss, right? Engrave means sunken down um, lines, so I emboss it protruding up, and then I paint it white. So since I have to change it anyway, I might as well just build the knobs to my specs that will fit this. Plus, I can just add the lines and emboss them. So starting with the channel knob, which is the easiest, then no line, no weird shape, just a cylinder. But because at the bottom, we are doing it to, we're using this typical small encoder. I like to do a D-shaped hole rather than a round hole. If you have a round hole and this is flat, you need a set screw at the side. Okay, if you do it this way, and if it's snug enough, it's not too loose and not too tight, if it's just fit over this, then it will catch this very well and there's no need for set screw. Okay, so this hole is quite small, 6.3, and then you add here a line and then you trim away this. Okay, now for the squelch switch, just two position on off. So if you go this like this, it's going to be 90 degrees, so this is like half of it, about 45 between the two positions, and in the middle is going to be half of that, about 22.5. Okay, so I use 45 degrees rotary switches and not 30, right? It's easy to determine the angles. So which means that if we want the line, this D shape, the flat side to be here, we want the line to be here. So then pointing to basically the initial position. Okay, when you turn counterclockwise all the way, if the line is here, and the flat side is here, then basically the block pin is here. So this will be at 22.5 degrees to the top. This is like true north. Okay. So, and the distance is always 9.53 and the lock hole is 3.5. So this thing is not random, okay? Because it's on the same position as the flat side of the D-shaped hole. It helps you determine where you want to set this hole, okay? You don't have to put many to use up one of them. You can calculate. You also need to know the knob that you're using and how many turns and where is the first position. All right, so now to make the knob, starting with the squelch is easy. We have the line indicator on the same side, okay, as the flat side, and where it points, that's the initial position here. All right, so this one just a cylinder, like the channel with a D shape, and then you add a line and pad this. However, note that this D-shaped line is much bigger. The D-shaped hole for a rotary switch is always bigger than the encoder because the shaft of the rotary switch is much thicker. All right, so these are proven dimensions. Rotary switch always use 6.6 by 2.4, whereas this one for encoder is just 6.3 and then 1.55. Okay, these two are very good fit. So I already mentioned this D-shaped holes, they fit better, no need for set screws. So next, the third knob, frequency knob. So this one, why we are building this again is because the original knob is too shallow. I think it's only like 5 mm deep. This one I make it taller, okay, 8 mm. As you can see here, the two holes, when you once you pad it goes up here 8 mm. It's slightly deeper and also wider, um, and it's going to be a good fit, and it can grip the encoder pretty well. So then we have this two part here in a straight line 4 mm, this 7 mm, then you curve and you join and you get this shape, okay, and you pad up 14 mm, then you fillet these two sides, maximum like 2.95. 3 you get an error, so once you curve it, fillet, you get this nice, you know, curve. Then you want to add this thing here, right? So two ways to do it. You can shift the sketch up and then pad down, or in this case, we move the sketch down. Okay, we draw a like a rectangle where this line is outside the circle. Okay, so that you, and then you move the z-axis of the sketch from the top here all the way down, so it starts here and then you pad up. Now from here to this top edge is 14, but we want this to have some height, so we we pad 15 instead of 14, so that this is 1 mm height. All right, and it's also protruding out by a little bit. So the thickness, you pad 1 mm, but the thickness I make it 1.25. 1 mm is a bit too thin. So, and how much it protrudes, how much is the height and how wide, it's all up to you. Okay, there's no um, hard and fast rule about this. So the last knob is for the mode switch. right? There are two of them, all 7 positions. So again, the D shape, we're using rotary switch, and you see here, this is the data sheet where you have the lock pin, which also determines your lock hole. It's facing the flat side of the D shape. So if you're having a knob here, this will be your rotary switch. And if you have your set screw will be here to put here and against the flat side, right? So if we put the indicator line on the opposite side, then the lock pin hole will be on the same side as the flat side and the set screw. Okay, so now and it's conveniently 45 degrees, right? This is like 90, this is 0, so 45. So in your sketch, you just draw your distance and the size of the hole at 45 degrees angle. So to make the knob, this is exactly as the way we built the frequency knob. Okay, again, fillet the size at the line, exactly the same. This one, I padded it down. Okay, so you can do either way. Now at the bottom, you just add a sketch and draw a bigger circle and have this shape here. This is like 1 mm radius, which means this is the whole thing is like 2 mm. So we have this shape here and you pad down, then you get this base, okay, with an opening here. This is how the knob looks like. So we are not done yet. You want to draw a D shape. Once again, for rotary switch is 6.6 by 2.4. Alright, and this will fit snugly on the rotary switch, and we're done with the knob. So we are done with all 4 knobs. So if you don't want to build all these knobs, you want to use the ones provided, okay, you can do so, provided you're using small encoders which will fit into the hole. But if you don't want this engraved line, you want to change to an embossed line as shown here, then you need to make this STL file editable. To do so, in FreeCAD, you first go to Part Workbench, okay, select Create Shape from Mesh, then you will, this is the beginning, right? You import, you click this, you get this, then you click on this, you choose Convert to Solid, okay, then you get this. Then you choose Create Copy, Refine Shape, then you get this. All right, then you select, you go to Part Design, okay, not just part Design, Workbench, and create the body, okay. Create the body, you'll get this body here, and you will automatically create this base feature, and then select your object and create a sketch, okay, to change from engrave to emboss. Now when you click this sketch, create sketch, it will, you select the whole STL file which has now been converted. It will have 3 planes, right? This one, X, Y, it's the only horizontal plane. You see this one here, the YZ and the XZ, they are all vertical planes, okay. So when you choose this, by default your sketch is going to be at the base, okay. If you want to add the line, obviously you can pad all the way, or you move the sketch up to just below this part here, okay. You move it up about 21 mm, and then you pad, your sketch, you create a rectangle and you pad just a little bit, like for my case 1.5, because there's some depth here. This is like 0.75, and then you go double, so this will be 0.75 and 0.75. Okay, the whole thing 1.75. So this is how you change an engraved line into an embossed line by first converting the STL. Okay, without converting the STL, you cannot edit. So now we look at the back panel. The back panel, we are we're using the kind of push buttons which has like two pins in the middle. So I will have the pins here. Okay, all the pins here. So if you have the pins here, the legs, you need to have space for the legs to go in. So this is one side, the other side go in here, the other side, the legs for of this go in here. So when you solder the wires, everything, they actually use up quite a lot of space. Okay, so this is how you do it. Now the lines here, we looked at the position of the lock pin hole earlier and determined that for this squelch switch, we want it to be here and our line to be here, our D shape to be here. So this is at 22.5 degrees northwest, right? For this two, we are starting the position here and we're having the line opposite the lock pin hole. So our hole will be here at 45 degrees northeast, right? This is the north part, northeast, and always 9.53 mm from the center, and the holes of the three lock pin holes are always 3.5. So the normally I have lock pin holes at the bottom of the top panel, but in this case we have it on the back panel, and the back panel is always only 3 mm thick. So you cannot see the hole, right? Because it's at in the back panel, you'll be covered by the top panel, so we can do a through hole. Okay, all the way. Then oh, notice here also we move the standard one, because we extended the Zeus hole. It's very close to the edge here, the original one. So I move it up. Okay, these are the 4.3 mm ones for the hex screws. These are the smaller ones for my 632 screws to combine to join top panel and back panel. So at the bottom of the back panel, you need to recess a little bit. Now, given this is 3 mm thick, I recess the space, the circles here, for the rotary switch to go in a little bit, but by 2 mm. 1 mm is not deep enough. 3 mm will fall through the whole thing, right? Become like this. So 2 mm is just nice. And then plus with the lock pin hole, it will hold this rotary switch in place while you turn. And actually the torque of the rotary switch is quite strong. And if you don't lock it, the whole thing will spin. So this is with a lock pin hole and a recess, it will hold it down, okay, securely, without spinning. Okay, so back panel is also done. So the kind of switches, this is relatively simpler than VHF and UHF. So we have many push buttons, we have two rockers, we have the big encoders for the frequency knobs, we have the small encoder for the channel knob, right? And then this two, this is the mode switch, this is the squelch switch. These two knobs use the rotary switch. All right, so basically like four kinds of switches and four kinds of knobs. All right, so relatively simple. Now for the screen. The screen, it doesn't get simpler than that. There is, compared to like CMSC, CMSP, the CDU, all need some kind of code in DCS Bios, and then run the DCS Bios via Arduino. So this one we are using Helios, and the whole thing is viewport. Okay, you just come to A-10C tool, drag this all the way, drop it in the second monitor. Okay, and then run your Helios, and everything will be displayed. Okay, it's very simple. So I chose this screen, 3.5 inch, so it works well. It seems a little bit too big. Okay, we have the power port here. We have the HDMI. This is a standard HDMI. It's not even a mini HDMI. Okay, that's on the back side. So this one here, it at the front there is this width that's quite big. So it eats up a lot of precious real estate, okay, in the panel. So you might want to consider a 3.2-inch screen. I wanted the screen to be as big as possible, right? But maybe it's not that necessary because it makes everything actually a bit cramped. All right, so here is the screen, right? You're only going to see this, but this additional space, it will eat up this space here. That's why I shifted everything to the left. Okay, and I omitted those lines so that I can have space here, and I want to stay away from the push button. Everything is very tight. Okay, you cannot go too far to the right. You also, this one, you cannot go too far to the left because we need to state the name of the panel here. So the compromise is to shift this a little bit to the left, omit the lines, have enough space here for this part. Okay, and here again we see the power and the HDMI. This one, you actually, it's going to eat into a space where the your throttle is going to be. So you should use a L-shaped adapter. Okay, from here you have the adapter L shape pointing down. Actually here is up, but it will be pointed down, and then have your HDMI cable away from the sides, right? So now DCS BIOS, the only thing to actually note is the radio. The other switches are kind of standard. The radio by default, in the default is always the simple view. In the simple view, I don't know why they are using this multi-position switch for all the frequency, right? 1, 2, 3, 4, 5. 5 frequency, they are using this multiple position switch, which means that all these are rotary switches. So this is a lot of wires and also very complicated. You need to have say 0 plus 9, 10. You need to have a 10 position rotary switch, and you need 3 of them, right? It's unnecessarily complicated. It still works if you use encoder, but the encoder is hidden in the advanced view of DCS BIOS. So just switch to advanced and use the encoder, which was just uses 2 pin, right? Instead of 10, 10, 10, like 30 pins. So this is what I'm using for the frequency. switches. Then I'm surprised to see that Eagle Dynamics hasn't really released a new user manual. So this is separate. This fighter group came out with the ARC-210 PDF. So I will provide this link in the description of the video. So inside one of the pages of the PDF, they mention all this, explain all this, and basically it's saying that this 4 and this enter, this 5 buttons in solid orange, they are not functional. So I didn't even bother wiring them. Okay, the rest are wired. So the only, besides changing this 5 true encoders from the rotary switch code, I also had to change this. All right, see the code here. The standard one is just 1 pin, which is kind of like a push button, but we know that this squelch switch is a 2 position. Therefore, we need to use a multi-position code rather than a 2 position code, which will only have 1 pin. So maybe it'll still work. I actually haven't tried. I saw this and it struck me that I needed 2 pins. So maybe the default 1 pin and the other one might not be needed. I don't know. But anyway, I use this code with the 2 pins. Everything else is standard, and these are rotary encoders as mentioned. All right. So this is the code. So everything is done. So now let's take a look at the panel in action.